In this video, I'd like to illustrate simple use cases for importing into R files that we've downloaded from external sources. So my three use cases will be: one, the importing of the results of a Peter Lynch stock screen from Stockopedia; two, importing price volume data for a stock that I got from Yahoo Finance; and three, importing historical bond yields for different bond rating categories that I got from the free database at Quandl. And by basic use cases or simple use cases, what I mean is when we are importing into R from either flat files or Excel. For flat files, we'll use the built-in command read.table or one of its many wrapper functions, and I'll show you what that means. And for Excel, we have several choices, but I'll show you the readxl package because it's super easy to use on Excel. In order to show you the base import function in R, I've written a simple R notebook file right here. It starts with a code chunk that's not relevant to the import. This just loads the screenshot images so I can show you where I got these files that I'm going to import. That's typical workflow, right? We go to a website like Yahoo Finance, find the data we like on a company maybe, hit the download button if there is one, and that oftentimes we get an option on the file format. How do we want an Excel, comma separated value? The download allows us to save that file to a local directory, and then we import into R, and I'm going to show you the import. Although I should mention that because this is R, of course we have many packages available to us which are improve on the base import, and it's almost a shame not to use packages in R when they're available to us. So among the many, here are four, at least that I've used in my training, that improve on the base import in R. Of course, the Tidyverse has a package called read.r written by Hadley Wickham. Any of these packages we install very easily with install.packages and then the name of the package, installs it, and then we can load that package with the library command read.r. Now we have the functions in that package available to us. It's that easy. Also, there's data.table is very popular. XL Connects is a powerful suite of functions. And then their fourth that I've used is the XLSX, which is focused on importing Excel. So any of those I would recommend. However, just for the base import here, our typical use cases are simple file example imports. And I define that as the need to import a flat file, or probably an Excel is the other common use case for me. Flat file formats tend to be either tab delimited or comma separated value. CSV stands for comma separated value, as you probably know. And then sometimes we see TSV for tab separated value. So before I show you the different functions, I really want to just show you why there's only one function, read.table, as I mentioned before. That read.table is part of the utils package, and I pulled up that help using question mark on the function. I use that help a lot. That brings up the R documentation, tells me that read.table is part of the utils package. When we start R, unless we've made modifications, the utils package loads automatically. So that's why I'm saying the read.table as an import is part of the base R. And I can see what packages are loaded with the search command. And we can see here, there's the read.r package that I just loaded a minute ago. But we also get the, among others, the stat package and the utils package. Anytime I start R, these are available to me. So search is telling me the utils package is loaded. So I'm getting any of it, I can use any of its functions, including the read.table. And then if I look down read.table, the reason I want to show you wrapper function is that we'll see there are lots of what look like variations on the read.table, including here's read.csv, which we will use to import a comma separated value. And if I went and did help on read.csv, that's something I've done at least a few times. The main reason I would call up help is to actually remind myself of the arguments and what their defaults are. So that's why I'm constantly using help, to look at the arguments of a function, because I don't remember them It's either that or the cheat sheets that I have. Read.csv, if I hit that, interestingly, read.table comes up because read.csv is under read.table because read.csv is just a wrapper function around the read.table. We really just have the read.table and then some wrappers. What do I mean by wrapper function? Well, here's a simple example of a wrapper function. I'm just going to define a vector, a numeric vector called series, but I'm going to slip in here this NA value so that if I then go run the mean function, that takes the average of that vector. Without any arguments, I get NA because this NA sort of infected my simple vector. Now I do have as an argument, and an important argument, na.rm, which stands for remove the NAs or strip the NAs, and its default must be false because it didn't strip it. So, but I can go in and set that argument to true. Now run the mean and strip the NAs out of my vector, and then I'll get an answer, or at least what I think is an answer. Alternatively, I could define my own wrapper function. I mean, there's no point in doing this here, but it's just to demonstrate a simple wrapper. I define a function wrap underscore mean, right? That doesn't exist anywhere yet. And my function, this says this is a function that takes as an argument x, and then there's really not much of a function here. It just wraps. It goes right to, it returns the mean function. However, it sets the NA argument equal, the na.rm equal to true. So that's my example of a wrapper function. I define my own function. It wraps around the mean function and just sets the NA argument equal to true. So it didn't exist. Now I run it. Now it does exist for me as a function, but it's just a wrapper on the mean function setting the NA argument, na.rm equal to true. And now if I run series on my wrap mean, I do get the same value of 3 without having to use any arguments. So it's trouble I didn't need to go to except just to illustrate that I can define a wrapper function by wrapping another function. And that's really all these do here. Read.csv wraps read.table. If we look at read.table, so read.table is the base function, and it turns out it's got many arguments. This might be a dozen or so. I haven't used all of them. But then read.csv is a wrapper on read.table, so calls read.table and then just, well, it only does a couple few things maybe. It it sets the sep argument equal to a comma because that's comma separated value. And so here's part of that file format is comma separated value. The fields are separated by a comma. And read.table has a default here you can see of null on the separate. So read.csv, well, it also changes the header you can see here. But for my purposes, what's significant here is it changes the sep argument. So you see how it wraps on read.table. And if I just hit read.csv, I think this will work without not running a function. I just want the name. I just want to see that function's read.csv. Notice here you can see this betrays the fact it's a wrapper function. It's actually calling read.table. That's part of the definition of read.csv. So read.table has a lot of different arguments here, although the ones that I've used are these. The file, we need, of course, to tell the read.table where the file is located that we're importing. The header is significant because that refers to the first row. Does the first row begin the data block, or is it the labels to the data, the column labels? And we could see, so this is why I'm constantly using the help documentation because I don't remember the arguments, but I just go back here, read.table, I see the default is false. So the default is there's no labels, then the first row is right away, the first is the start of the data block. Sep and quote, well, these two are important because these are the definition of the file format. And if a typical comma separated value, I actually think comma separated value can mean two different things to people depending on the quote. But one way we might get a comma separated value is, and I'm being very super simple here on the value, the A is contained in quotes, and then we comma to the next field, and then a B is in quotes, and then we comma. Comma is the separator to the next value. So these can be the columns, and they're separated, SEP, by commas, but they also may or may not be in quotes. So that's the meaning of these two arguments. The sep here tells the read.table what separates our fields. And you will notice that read.table has a default here of really the two quotes go right and immediately. So that's a null. And if we go further down in the help, which I can't do now because I'm drawing, is the null is used to signify white space. And if you've imported files before, you've seen this before, I'm sure. Oftentimes it just comes in as spaces. So white space, the null would be used for spaces, but if we have commas, then we need to tell the separator that we're using commas. However, that's the point of the read.csv wrapper function. It's calling read.table, but you see here, it's for the sep argument, it's setting it to a comma. The quote here refers to whether or not there are quotes containing the values in these fields. And you can see here, this default may look awkward at first, but it's using the backlash to escape. And R is not the only language. This is common in C and other languages, I believe. But you could see we have really here name value pairs for the arguments. So if we wanted to do quote, it might be our tendency, right? We know we're going to put whatever the ASCII character is inside quotes, right? Because these are ultimately just ASCII characters, a quote, a comma. If it is in fact quotes, we might be tempted just to put a quote, right? A quote inside a quote means quotes. But the machine's not going to read it this way. It's going to encounter the first quote and then the second quote, and it's going to think it's finished with the name value pair because that's the second quote, and it's going to read this as a null. We can understand that. So we need to escape this quote here, escape it from the name value sequence, and tell the machine to read it literally, right? So that's very common. Good to know that we need to backslash our literal characters to escape them from the reading of it as the end of the name value pair. Now the machine knows, okay, here comes my ASCII character. Okay, backslash, I need to take this literally, so it's a quote, and now I've finished my name value pair. So that's why that's there. But together you can see these really define, sep and quote, they define the nature of the file format import. So when importing, at least my experience, that's the nature of the debugging. When I don't get it right, it's in the sep quote arguments. We also have call.names, whether or not there are column names. And then the string as factors. Anyone who used R for a little while knows about this quirk. It's one of the quirks or endearing features of R. No, it's not really endearing. It's just irritating. The string as factors will default to importing strings as that's character values, character vectors as factors, which are categorical. And typically on default, we don't want to do that. So in base R, we typically need to overwrite strings as factors and set that to false. Okay, so then I'm just going to go right away to using the import on that first external file that I loaded. And here I'm going to plot it just to show you. I went to my Stockopedia account. Like many stock screeners, it has a screen. I screen on Peter Lynch. The Peter Lynch, so the short list of companies come up that pass the Peter Lynch screen. It includes like a low peg ratio, and I get a table. I get a table output, and then I could download that file. And in this case, I download it to tab separated values. So it's a tab, not a comma that's separating the fields. And then So one of the things that's always important to do here is to get the path right. That's the location of the file, that the path and the file name. So here's WD is my working directory, and then I define a path. I like to use file path. The file path command will just take, if I separate by commas, here I've got the directory location, and then it's a file subdirectory. So you basically string together or chain together the directories, and then you see here in the file path, I'm also including the name of the file. So here it's the path, what we typically call the path location, my directory plus my subdirectory. The reason I like the file path is that I don't need to worry about the // that separates the directories, frankly. And so you can see if having run that, if I do path, I've got the location, the path to my file, including the file name, just nicely in a single variable. I really like to do it that way. And then now I know that Peter Lynch screen is a file. Now it's in txt, and I happen to know that it's because I looked at it in Excel, that it has a header. So I'm very simple now to do my base import. Read.table, here's the location. Header, it does have a header. The first row is the labels, and then it's separated by tabs. So I need to set that sep argument, and then I'm using for a tab, I'm using here the /T. So that's not the escape. That's just the code that stands for tab. And it's not here in the help. I'm not sure where it's in the help and why it's not in the help. But there's a limited set of special characters like that when we have a tab or a carriage return. But forward or /T tells that what separates my field is tabs. So that if I run that, I get my Lynch imported, and that's a base import. That's all there is to it. And RStudio is so great because you've got this, and then I can just hit this right here, and I can see my file. It's loaded for me. I've got it available to me as the Lynch object because that's the name I gave it. And you can see I used header true because these are part of that file. Okay. Now, the wrappers. I mentioned the wrappers. If I go down here, we have read.delim is a wrapper on read.table, and you'll notice the key idea with the wrapper delim here, is that I have the separator set to /T or a tab. And also it sets my header to true so I can see what else it does, but not worry about that now. Including the decimal, I think that refers to whether, it's a, or what character is used as the decimal. So knowing that, I can use my wrapper function without setting any arguments, right? I'll redefine Lynch now by simply using the read.delim function, and you can see in that case, all I need is the path. But now you understand that I'm just calling the wrapper function around read.table, where the read.delim is setting header equal true, and the separator as telling it the separator is in fact the tab. The next one I went to, now this is a case where you can see I went to Yahoo Finance right here, and then I hit download data. I think I had choices, I can't remember, but I used, what's very common is I use the comma separated value, and we can see that I've got that file extension .csv. And so I can just run read.table, and I do need to tell it though that what's separating the fields in the comma separated value, by definition a comma, and in this case I also have a true. And so that defines my object, Cloudera, or really a data frame object. Hit that, and you can see I get nicely my series of data. And then alternatively, I can call the wrapper function .csv, and it is a wrapper function that sets the sep argument equal to comma, so that I didn't use my path variable here. All I need, I can run read.csv without any arguments at all and just import the file directly. And finally, Excel, the need to import Excel is also a very common function. Of course, a typical workflow there is to save the Excel as a separated value and then use the read.csv to import. But it's very easy also just to use readxl as part of the tidyverse. So I've already run install.packages read xl, and then I just want to make sure it's loaded because I haven't done that. Readxl, and load the package. And that is going to give me access to the two functions I want to use. Although, let me just run these commands, including plotting, where I got this data. So I got this data from Quandl, and this is just corporate yields for different bond rating categories, including AAA, for example. So I went to Quandl. It has some free data, and I downloaded the free data into an Excel format. And then the path of I'm going to define path XLS as where that's located. So having loaded the readxl package, it has a function here. I'll separate it. Excel_sheets, and I think having loaded that I should have available. Yep, it's help over here. List all the sheets in an Excel spreadsheet. Usage is very simple, so that if I run that command. That's kind of cool. It's giving me a list of the sheets in that Excel file. And that Excel file has 5 sheets. And that's because I went to Quandl. I imported for each of these, the yields for each of these bond ratings. They come in as separate sheets. I combined the sheets, and then I aggregated the sheets into a single sheet at the front. And I called that all. So that this is Excel sheets is telling me what sheets are in my workbook, and I can see that the first sheet in my workbook is called all. And then the package is really cool. It has the readxl command, and it takes the path, and then it has an argument. If I go, and that argument is, you can see here, sheet equals null. Sheet is the argument. The sheet to read, either a string, which can be the name of the sheet, so or an integer. And you can see I have sheet equals 1, telling it just read for me that first sheet. But it looks like I could also just say sheet equals all if I having run the Excel sheet. So let's see, and yields comes in. RStudio gives me the view. I've now, with that single command, imported the Excel into a nice, clean data frame. I love that. And then I'm just for fun going to show you around it's very easy to run ggplot and plot two of those columns, right? Here's it looks like I plotted AAA against investment grade against triple C. That's pretty close to defaulting. I can just visualize a credit spread between those two. There's a yields between those two credit ratings very simply in a single ggplot command. But the point of this was the import. So that's readxl package, very easy to use with the two commands that were Excel sheets and readxl. So that's just an introduction to, we looked at reading flat files, where we saw the key to reading flat files is to get that separator quote set of arguments correctly. Identify what do we mean by the definition of that flat file, which really boils down to what's separating the fields. Is it blank? Is it comma? Is it tabs? And then is there a quote character or something like that being used to separate the values? If we get that right, we can import the flat file. And then for Excel, we have We saw there are some advanced packages, powerful packages, but we could also just use the very straightforward readxl package that is also part of the tidyverse in addition to readr that's part of the tidyverse. So I hope that's helpful. If it's helpful, subscribe to the channel and then you'll get notified the next R video that I do. Thanks very much.